Hi viewers, this is second part of composite function as well as inverse function. So here we will solve few questions related to composite and inverse function. Little bit different techniques. So let's have a look when we have quadratic functions, how to find out the composite as well as inverse. So first one, we have g of x which is equal x square minus 2 and h of x which is equal to x plus 5, and we are looking a part, and in a part we have the composite function h g of x which is equal g h of x is given, remember it is 2x plus 5, and then we have to replace back this 2x plus 5 in function g, and we know that is g of x equal x square minus 2. So in place of x, now I will replace 2x plus 5 whole squared minus 2 and then try to simplify, which is equal 4x squared plus 25 plus 2ab, that gives me 20x minus 2. We can simplify more. We can say that 4x squared plus 20x and plus 23. So this is gh of x. And in second part, they want us to solve this equation gh of x equal 14. So gh of x equal 14, and we have given 4x squared plus 20x plus 23 is equal to 14. So it is equal 4x squared plus 20x and plus 23 minus 14 equals 0. I will try to make quadratic equation so that we can apply quadratic formula or factorization concept. So 4x squared plus 20x, 23 minus 14 gives us 9. And see, if first we think about factorization concept, so we must to know what is product is here. Here we have 36x squared and some value is 20x. So if I think about two numbers which we multiply to get 36, like 18 into 2, that gives me 36, and 18 plus 2, that gives us exactly 20. So it means we can say that 4x squared plus 18x plus 2x plus 9 is equal to 0. Now we can think about group factorization. So in first part it is 2x common, so 2x plus 9. In second part nothing is common, so we can take 1 as common, so 2x plus 9. And here we have 2x plus 9, bracket open, 2x plus 1 which is equal to 0, and we are looking solution means value of x. So one value you can get from 2x plus 9 equals 0, and the second value 2x plus 1 equals 0, which gives us minus 9 or minus 9 by 2. And from here 2x is equal to -1 or x is equal to -1 over 2. It means we are getting two answers. One answer is minus, if we change it to mixed numbers, so 4 1 over 2, or the second answer is minus 1 over 2. So these are the answers of x which they want us. I hope so it is understandable. Next we have another question, which is f of x is equal to k minus 2x for x belongs to R, and g of x which is equal to over x. Two functions are given, and where x naught is equal to 0, find the value of k for which the equation f g of x is equal to x has two equal roots. So here we will think about discriminant rule. That rule says what? If you have b square minus 4ac is equal to 0, that means we have equal roots. Okay, this is for equal. And if you have b square minus 4ac greater than 0, that means we have different or distinct roots. Different roots. And if you have b square minus 4ac less than 0, that means we have no real roots. No real roots are, we can say that, imaginary. Anyway, here we will apply b square minus 4 is equal to 0 at the end, but before that we will use composite concept for f g of x, and f g of x is equal to what? We will keep same f and g of x equal to over kx, and then replace 2 over x in the function f, which is k minus 2 in place of x. We can say that 2 over x, or one more step, we can say that it is 2 2s are 4, 4 over x. After this, we cannot simplify more. If you want, we can take LCM. So kx minus 4 over x. But as we know that f g of x is equal to x. So f g of x equal kx minus 4 over x is equal to x. So here we can think about cross multiplication. That means kx minus 4 is equal to x squared. Try to reshuffle or rearrangement like x squared minus kx plus 4 is equal to 0. Now it's a quadratic form, and in this situation we have a is 1, b is equal to negative k, and c if you compare with quadratic equation. Okay, now our discriminant is what? As they say, the roots, two equal roots, so we can apply b square minus 4ac equals 0. So b is minus k whole square, and for a is 1, c is 4 equals 0. So k squared minus 16 is equal to 0. So k square is equal to 16. So if you apply square root on both sides, we will get plus minus 4. So these are the possible values of k we are getting, which are plus minus 4. I hope so you get it. We move on next. Next is inverse function. F of x is equal to x plus 1 whole cubed minus 4 for x belongs to R, x greater than or equal to 0. Find an expression for f inverse x and find the domain of f inverse x. Remember that generally we write f of x is equal to y. In this situation, x represent domain and y we say range. Once you change this function into inverse, sorry. So here now x is what? X is range, and this one change into domain. So remember, once you change normal function into inverse function, so domain and range will change. Okay, the domain of function f will convert into the range of f inverse. Okay, that we will discuss or we will apply at the end of this question. But before that, this one, find an expression for f inverse x, we will apply simple rule like basic techniques, like we change or replace the value of f of x. In place of f of x, we will write y, then shuffle x and y, and then make subject y, and then at the end we will say it's inverse function. So let's have a look. First thing, we have f of x is equal to x plus 1 whole cubed minus 4, and this is the first step. We say f of x always equal y, and this is equal x plus 1 whole cube minus 4. So remember that the second step, we have to shuffle or change or interchange x and y. Means in place of y I will write x and y plus 1 whole cube minus 4. And after this, the third step, we have to make the y as subject. Means x plus 4 is equal to y plus 1 whole cubed, or we can say that y plus 1 whole cubed is equal to x plus 4. We are trying to remove cube by taking cube root both side. Okay, so next we can say that this cube can cancel cube root. We have y plus 1 is equal to cube root of x plus 4. If you take one other side, it would be minus 1 plus cube root of x plus 1. So this is our required inverse function, which is equal minus 1 plus cube root of x plus 1. And remember that the second thing, as I already discussed, the domain of this function, which is x plus 1 whole cube minus 4, is the range of f inverse. But we are looking domain of f inverse. It means what is the range of this function. For example, I'm doing work on B. I have f of x, and it is equal x plus 1 whole cubed minus 4. So I'm going to check at this uh, value of x greater than or equal to 0. This is the domain of this function. So I'm going to check what is range can be, okay? So if I check at x is equal to 0, f of 0, 0 plus 1 whole cube minus 4, that gives me 1 minus 4, which is equal minus 3. So remember that this is our minimum value. After this, you can find out the bigger values. For example, if you check at 1 it would be 1 plus 1 2, 2 cube means 8, 8 minus 4 5. So after this you will get the bigger values. I can check also. So if you check at 1, 1 plus 1 whole cubed minus 4, that means 2 cube minus 4, 8 minus 4 gives me 4. So this is positive value. So after this, if you substitute any value of x which is greater than 0, you will get bigger values. So it means this is your least value, and after this you will get bigger values. So that is the range. So if you want to write the range of this normal function of f of x, range is f of x greater than or equal to minus 3. But as we are looking the domain of f inverse, so I would say the range of f of x is the domain of f inverse x. Okay, so domain of f inverse x is, as we are saying domain, so I would preferably use to x. Okay, x greater than or equal to minus 3. I hope so you understand. We move on next. Next is f of x 2x squared plus 12x minus 14 for x belongs to R and x greater than or equal to k. Remember that this is U-shape quadratic equation, and whenever you have quadratic equation, we always have many one function, not one. So now inverse function can be exist only if it is one function. For many one, it's not possible. Okay. So for which value of k this function is possible, so that we can say that it's 1, and for what value of k help us. So I will do a little bit work on function f, which is f of x is equal to 2x squared plus 12x minus 14. I will take the advantage or the help of completing square concept. So I can say that let's suppose 2 is common. So x squared plus 6x minus 14. I'm trying to complete square here like as a perfect square. Okay. So 2x squared plus half of 6 is 3. So we will add 3 square and as well as subtract also. Okay. Minus 14. That means 2. So here we can say that x plus 3 whole squared. And this 2 is multiplying inside also. So 3 square gives us 9 minus 14. That means we are getting 2 bracket open x plus 3 whole square. 9 twos are 18, 18 minus 14, 2 bracket open x plus 3 whole square. So this gives us minus 32. That is, we applied completing concept, completing square that help us to figure it out the value of k, and they say find the least value of k. Okay, and later on we will find out inverse also. That would be easy. So look here. Basically, I already mentioned it's a U shape. Okay, U shape. U shape. For U shape, we will find out the minimum value. What is the minimum point or value of this? So that minimum value you can find out like by putting for which value of x gives you 0, this statement. Okay, that if you think carefully, that x equal minus 3 means at x is equal to minus 3, I can say that minus 3 plus 3 whole square minus 32. That means 2 into 0 whole square minus 32. So I'm getting minus 32 for value of x minus 3. It means my minimum point is when x is minus 3, the y value is minus 32. So this is our minimum point, or we can say that a turning point as well. But from here, you can get the value of k as well. So if x is 3, so x and k are greater than or equal to. So if you say x is equal to minus 3, that is k is also minus 3. So for this value of k, we have one function, and then you can find out the inverse. Okay. Now we move on B part, and in B part they say what is the inverse function. So I would say that I already have f of x 2 bracket open x plus 3 whole square minus 32. So we usually supposed to say that this f of x equal y, which is equal to bracket open x plus 3 whole square minus 32. And then the second step is we interchange the x and y value. Means x is equal to 2 bracket open y plus 3 whole squared minus 32. And after this we will try to make y subject. So for that I will do the work. X plus 32 is equal to 2 bracket open y plus 3 whole squared. Try to rearrange 2 bracket open y plus 3 whole squared is equal to x plus 32, and then we can say that y plus 3 whole square is equal to x plus 32 over 2. By cancelling a square, we have to take square root both side. Okay, so once you take square root, square can cancel square root, so we have y plus 3 is equal to square root of x plus 32 over 2. And lastly, you can say that y is equal to minus 3 plus square root of x plus 32 over 2, or this y represent f inverse x, which is equal minus 3 plus square root of x plus 32 over 2. I hope so you understand the second part of this video, which is relates composite function as well as inverse function. Bye.